The steering gear system you see is a rotary vane type electro-hydraulic steering gear. There are two sets of hydraulic power packs comprising of hydraulic pumps and oil reservoir. The bidirectional control valve changes the direction of oil flow. Electrically operated automatic isolation valves isolate the defective system in case of emergency. Combined shock buffer relief valves maintain the system oil pressure within limits. The control box receives helm order from bridge and sends electric signals to the bidirectional control valve. Potentiometer senses the rudder stock position and sends a feedback to the control box. Check the hydraulic oil level in the tank. Insufficient hydraulic oil level will lead to poor performance of the system. However, alarms are provided to warn the operator. Check whether power supply is available for both the steering motors. Standby steering motor power supply should be available for emergencies. The steering pump motor is started. The number 2 pump starts running. The amperage of the pump motor is checked. Electrically operated isolating valve of the running pump is kept in open position against spring pressure, and the isolating valve of the standby pump, when no helm is ordered, the bidirectional control valve is in mid position. When port order is given from the bridge, the bidirectional control valve moves to the left. Pressurized oil is pumped into rotor. The pressurized oil moves the rotor vanes. The rotor in turn moves the rudder stock to port side. The return oil flows back to the pump return side. When the rudder stock reaches the desired helm angle, the potentiometer sends a signal to the control box. The control box sends a signal to bidirectional control valve. The valve is pushed back to its initial position. This blocks the oil flow and stops the movement of the rotor. When starboard order is given from the bridge, the control box sends a signal to bidirectional control valve. The valve moves towards the right. The pressurized oil is pumped into the other side of the rotor. The pressurized oil moves the rotor vanes. The rotor in turn moves the rudder stock from the port to starboard position. The return oil flows back to the pump return side. When the rudder reaches the starboard position, the potentiometer sends a signal to the control box. The control box sends a signal to the bidirectional control valve. The valve is pushed back to its initial position. This blocks the oil flow and stops the movement of the rotor. Consider during the operation there is a fracture in one of the pipes. The oil starts leaking and oil level starts dropping in the oil reservoir. The low level alarm is raised. If the leakage is severe, then low level alarm sounds and auto isolation takes place in the following way. The number 2 steering motor is shut down. The isolating valve also shuts down. Number 1 pump is started and the number 1 isolation valve opens. Thus, the system 2 is isolated and system 1 is put in use. Consider a port order is given from the bridge and suddenly the power supply fails in the control unit. In such an emergency, an alternative communication system is used to give the helm order to the steering compartment. The bidirectional control valve is manually actuated by using the levers. For instance, when the right side lever is operated, the bidirectional control valve moves towards the right. The rotor in turn moves the rudder to the port side. When the desired rudder angle is achieved, the manual operator releases the lever and the valve comes back to its initial position. The steering gear system is shut down when the ship reaches a port and berth alongside the jetty. The steering pump motor is switched off.